Section 3.4, the quadratic formula. So our objective for this lesson is to solve quadratic equations using the quadratic formula, analyze the discriminant to determine the number and type of solutions, and solve some real-life problems. Okay. So first, let's go ahead and let's go over our solving quadratic toolbox so far. We have a lot of different tools in our toolbox that we can use to help us solve quadratics. And which one we use and which one's easiest depends on the type of quadratic we're solving and how it's given to us. Okay. So again, remember our graphing works really only, first of all, when you have a calculator handy. And also when your solutions are nice numbers, is when you have what I call nice numbers. Okay. Our nice whole numbers, 5, even a half, graphing will work to help us find those ones. But again, you need to have a graphing calculator, and the solutions need to be nice little numbers. Okay. Square roots. We can use square roots, but again, that only works when you have something squared with an x in it here equals something with just a number. Okay. And we don't actually get equations written that way that often. Okay. But if it is written that way, we can just very easily square root both sides and get to our solution that way. Okay. Factoring. This works again if the trinomial is factorable. Not all trinomials are factorable. Not everyone, not all of them will factor. And so if they won't factor, we can't use that method. Okay. Completing the square will always work. So that's one that we can always come back to. It will always work, but sometimes it's messy. Sometimes it's messy. You get the really crazy fractions where it just gets a little messy to do, but it will always work. So really, our completing the square is our go-to right now. Okay. But I don't know about you, but I wish there was an easier way than completing the square all of the time. For one, it's a lot of work and it gets to be really messy. Okay, so we're going to look at an alternative to completing the square. And how we're going to get there is we're going to complete the square on a quadratic, a just general quadratic. So we're going to complete the square on one that's ax squared plus bx plus c equals 0. So again, a, b, and c could be any number. Okay, a, b, and c could be any number. So we're going to complete the square on this, okay, so that way we can look for a shortcut to completing the square. We're going to do it once and see what we get and see if that could help us. Okay, so first of all, I'm going to complete the square. Normally with completing the square, whatever's in front of this x squared, we want it to be 1. Right now it's an a. So I'm going to come through and I'm going to divide before we do that, sorry, let's back up a step. Let's subtract the c to the other side. Okay, equals negative c. So we subtracted the c to the other side. Okay, now I want to get rid of this a out in front here. So to do that, I'm going to divide, because it's a times x squared, I'm going to divide everything times a. And by everything, I mean everything. I even have to divide this thing by a. So we're going to divide this by a, and this by a. We're dividing everything by a. So when I divide this by a, I'll have x squared. Now here I'll have b over a, x equals negative c over a. Okay. Now we're going to complete the square. Okay, so I should have left a space here, so let's move my equals over. So to complete the square, we take what's in front of my x here, so we're going to take this thing here, and we're going to bring it down, and we're going to cut it in half. So to cut it in half, I'd have b over 2a. And then we're going to square it, and that's what's going to go here. But then we also need to add that to the other side. So we'll have x squared plus b over ax plus, when I square this, I'll have b squared over 4a squared. So then I need to add that to the other side. All right, now this part over here will actually now factor. It's going to factor into x. And again, if you remember how completing the square worked, it's going to factor into x plus that. So x plus b over 2a times itself squared. Okay, now let's put this fraction together. I need a common denominator here, so I'm going to multiply the numerator and denominator by 4a. So I'll get a denominator of 4a squared, so I'd have negative 4ac all over 4a squared plus b squared over 4a squared. So I just got a common denominator so I could add these two fractions. So I have x plus b over 2a squared equals. And now let's just go ahead and let's flip-flop this. So I can put my positive first, so I'd have b squared minus 4ac all over 4a squared. And now we square root both sides, right, to get rid of the squared. So let's square root this side, let's square root this side. Okay, so now let's take it up over here. So we'd have x plus b over 2a equals plus or minus, remember when we square root both sides, and let's square root the numerator, which is b squared minus 4ac over, let's square root the denominator. Well, I can't really square root anything in here because that's a subtract, but I can square root the 4 and I can square root the a squared. So when I square root the 4, I get 2. When I square root the a squared, I get a. So over 2a. And now let's subtract the b over 2a to the other side. I'm just solving for x. So you have minus b over 2a plus or minus the square root. Well, they have the same denominator, so I can put them together as one fraction. Okay, so now we have x is equal to this thing, but this is only in terms of a's, b's, and c's. Again, with my a, b, and c being those numbers here. The a is in front of my x squared, the b is in front of my x, and the c is my constant. And when we're solving, isn't our goal to figure out what x equals? So now I know x equals this thing, okay? This is what we refer to as the quadratic formula. And what I just worked through is actually the proof. This is the proof of the quadratic formula, where it comes from. Hey, and how this is useful is I can actually figure out what x is just by doing this, plugging in my a, my b's, and my c's from the original equation. Okay, so I'll show you an example. Kind of out of room here. Okay, so in this equation here, I have x squared plus 3x equals 5. I'm going to subtract the 5 to the other side. Minus 5. Okay. And so then now I can see my a is my number out in front of here. My b is my number in front of there, and my c is there. So off to the side we'll say a is 1 then. My b then would be 3. And my c then would be negative 5. So I know my a and b and my c, so then I can solve for x. All I need to do is write the quadratic formula down. Negative b plus or minus the square root, b squared, minus 4ac, all over 2a. X equals that. So I want to find what x equals, right? That's my goal. Now all I need to do is plug in my a, my b, and my c into this. So I want negative b, that would give me negative 3, plus or minus the square root of b squared, so that'd be 3 squared, minus 4, times a is 1 times c is negative 5, all over 2 times my a is 1. Okay, let's bring it up over here. So my x now is going to equal negative 3 plus or minus the square root of, now let's simplify, 3 squared is 9, minus 4 times 1 times negative 5. 4 times 1 is 4. So that would be positive 20 all over 2 times 1. So we get negative 3 plus or minus the square root of 29 over 2. So now we look to try to simplify this if we can. Square root of 29, and I don't think that simplifies any. 29, I believe, is prime. So my two solutions are negative 3 plus the square root of 29 over 2, and then negative 3 minus the square root of 29 over 2. So let's go ahead and let's check our work here. Let's go to my y equals, and let's graph the original equation, which is x squared plus 3x minus 5. Okay, and let's see if these are in fact 0. So let's look at the graph. Okay, let's trace. I want negative 3, oh wait, parentheses, negative 3 plus the square root of 29 divided by 2. Yep, it's 0. So let's go parentheses negative 3 minus the square root of 29. I need double parentheses there for the square root and the divided by 2. And that one is also 0. So there are my two solutions of this equation. I did not have to complete the square because I completed the square already to get to this thing. Okay, so then I can just, now that we've completed the square to get to this, now I can just use this to solve equations. Nice. Okay, let's go ahead, next problem. Oh, your turn. Now it is your turn to do some problems. So now you have your turn number 1, problems A, B, and C. I want you to do all 3 of those, again, using the quadratic formula. Every time you use the quadratic formula, please write it down. Identify where your A, your B, and your C are, and just plug them in and simplify. Okay, here example 2. Again, solve using the quadratic formula. Well, I need to figure out my A and my B and my C. So I need to get it to look like that. So I'm going to have to do a little bit of arithmetic. So I'm going to go ahead and I'm subtract. So we have 25x squared minus 8x. I'm going to subtract the 12x over and add the 4 over. So we'd have 25x squared minus 20x plus 4. Okay. So now we just use our quadratic formula. So I need to write that down. First of all, there's my A. My B then would be negative 20. My C would then be the 4. So x equals negative b plus or minus the square root. If you don't remember it, flip back to the other side and jot it down. So my negative b. My b is negative 20. So if I take a negative of negative 20, that would be positive 20. So I need to take negative 20 and square it. Minus 4 times A is 25 times C is 4. 2 times 25. Okay, let's bring it up over here. So my x is going to equal 20 plus or minus the square root. Negative 20 squared, I believe, is 400. Minus 4 times 25 times 4 is 400, so minus 400 all over 2 times 25, which is 50. 400 minus 400 is 0, so we get 20 plus or minus the square root of 0. Well, the square root of 0 is 0, so we get 20, so 20 plus or minus 0 over 50. Well, 20 plus 0 is 20, 20 minus 0 is 20, so really we get 20 over 50. So my x equals 20 over 50, which simplifies to 2/5. So my x is 2/5. Let's go back, let's double check this. So this only has one solution. Minus 20x plus 4. Let's go ahead and let's graph it. Trace. 2/5. Yep, and it looks like that's the only one. If we change our window, let's go negative 5 to 5. Zoom in a little. Yep, we can see that it only touches right there. That's it. So my solution is just plain old 2/5. All right, let's go ahead and let's do another one. Okay, solve using the quadratic formula. Again, I need to get it in ax squared plus bx plus c form. So ax squared plus 4x, let's subtract the 13 over. Okay, so I can tell my a here is that negative 1, my b is the 4, my c is the negative 13. So x equals negative b plus or minus the square root all over 2a. Okay, let's plug in. Negative b, my b is 4, so negative 4. The square root of 4 squared minus 4 times my a is negative 1. My c is negative 13. All over 2 times a, which is negative 1. Okay, now let's bring it up over here. We're out of room. X equals, so negative b plus or minus the square root of 16 minus 4 times the negative 3 times the negative 13. So negative, and again, negative 4 times negative 1 times negative 13. It's going to be negative 52 all over negative 2. Okay, so we get negative 4 plus or minus the square root of 16 minus 52 is a negative 36, or negative 2. Okay, plus or minus. The square root of negative 36. Square root of a negative is I. Square root of 36 is 6, so that would be 6i. Now both of these divide nice by negative 2. Okay, so let's just write my two equations. We have negative 4 plus 6i, all divided by negative 2. Negative 4 minus 6i divided by negative 2. So if I simplify, negative 4 divided by negative 2, that gives me 2. 6 divided by negative 2 minus 3i. And then it would give me 2 plus 3i. So there are my two solutions, 2 minus 3i, 2 plus 3i. So this had imaginary solutions. Okay, so we can still get to our imaginary solutions by using the quadratic formula. Okay, so again, now you have 3 more your turn problems. I want you to do your turn problems A, B, and C. Okay, again, use the quadratic formula, simplify as best you can, come to class with any questions that you have. Next. Okay, the discriminant. In the quadratic formula, okay, there's our quadratic formula. The discriminant is this thing underneath the square root. That is the discriminant. And the discriminant tells us what type of solutions we're going to have. Okay? If the discriminant is positive, like here in example 1, our discriminant was the square root of 29, which is positive. Our discriminant was 29. Again, 29 is positive. So since it's positive, I had 2 real solutions, okay, since my discriminant was positive. Okay. So if the discriminant here is positive, like in this case, if the b squared minus 4ac is positive, then you're going to have 2 real solutions. So that tells me it's going to have 2 x-intercepts. If the discriminant of whatever is inside of there is 0, like we had with example 2, it was 0 inside of there, then you just have 1 real solution. So you'd have 1 real solution, so it would have 1 x-intercept. If the discriminant ends up being negative, like we had in example 3, my discriminant ended up being negative 36. So then I had 2 imaginary solutions. So that tells me there's going to be no x-intercepts. Okay, so we can tell just by looking at that b squared minus 4ac. And is it positive? Is it 0? Is it negative? We can say what type of solutions will we have. Okay, so this is just a quick little check. If I want to say, okay, how many x-intercepts is it going to have? Okay, I can just look at that discriminant and tell. Okay, so it says find the discriminant of the quadratic equation and describe the number and type of solutions of the equation. So we don't actually want to find the solutions. We just want to say what kind are they. So we want to do that b squared minus 4ac. And see what we get. So again, my a is in front of here, my x squared. My b here would be negative 6, my c would be 10. So I want to take negative 6 and square it, minus 4 times a times 10. So that would give me 36 minus 40, which is negative, right? 36 minus 40 is negative. So it's negative 4. So this tells me since it's negative, it's going to have 2 imaginary solutions. So describe the number, there's 2 of them, and type imaginary solutions, just by looking at that discriminant. So I know it's going to have 2 imaginary. There's going to be an I in there somewhere. Again, we didn't actually find what they are. We just know there's going to be 2 imaginary ones. Okay. All right, so let's go ahead and let's do it again. So we want to do b squared minus 4ac. So there's my a, there's my b, there's my c. So b squared, negative 6 squared minus 4 times a times c. Negative 6 squared is 36 minus 4 times 9, 36. So I get 0 for my discriminant. So that tells me there's going to be just 1 real solution. Okay. And let's do it one more time. B squared minus 4ac. There's my a, there's my b, there's my c. So we'll have b squared, so negative 6 squared minus 4 times a times c. So 36 minus 4 times 8 is 16, 16, 32, which gives me 4. So we get a positive discriminant, so that tells me there's going to be 2 real solutions. Okay, 2 real solutions. So now I want you to find the discriminant of these quadratic equations. So find the discriminant like we did up here. This one was negative 4. Okay, and then just tell me, describe the number and type of solutions of the equation. Okay. All right, so on the back side here, I've added solving a quadratic toolbox. Here's all our tools. We have 5 tools in all now. Okay, and we're going to write down, we're going to fill in some notes on this in class tomorrow. So make sure you bring your notes with all of your turn problems attempted. So you've got your turn problems 1, your turn 2, and your turn number 4. Okay, so come to class with all of those finished. Try to get them done so we can discuss them in class. We want to make sure you have something to bring to your group, and we will answer any questions that you have, and good luck.